Good afternoon, everybody. We are going to be starting Chapter 6, Lesson 2 today, and we're going to be talking about another type of transformation known as a reflection. So, just like a translation is a slide, a reflection, in easier terms or simpler terms, is a flip. Okay, so we flip it over a line. The two most common lines of reflection that we will see, or what we're flipping it over, is going to be the x-axis and the y-axis. And depending on which one we're flipping over determines what our action is. So here, in words, it says to reflect a figure over the x-axis, multiply the y-coordinates by -1. In our transformation notation, we go x comma y to x comma -y. All right. So here, let's see. It's hard to tell which one is our image and pre-image, but if we just say this is our pre-image, from here I went from -4, 4 to -4, -4. So that flipped down all the way over there. Here I went from -4, 1 to -4, -1, and -2, 1 to -2, -1. Notice I changed the sign of all of my y coordinates. Now, reflecting over the y-axis is exactly the same, except instead of changing the coordinate or changing the sign of the y coordinate, I change the sign of the x coordinate. So -4, 1 turns to 4, 1. -2, 1 turns to 2, 1. And -4, 4 turns to 4, 4. All of my x coordinates have changed. Okay, hopefully you guys can see that. It looks a little blurry. Maybe I'll try this. Well, hopefully we're following along in the book, so if anything looks a little blurry or hard to read, you can see it in print. So, in words here, a reflection is a mirror image of the original figure. It is the result of a transformation of a figure over a line called the line of reflection. So the two lines of reflection that we work with are going to be the x-axis and the y-axis. In a reflection, each point of the pre-image, that's our starting point, and its image, the ending point, are the same distance from the line of reflection. So in a reflection, the image is congruent to the pre-image. So the figures are congruent, which means they are the same. But if you notice, here we reflect it over the x-axis, so that would be our line of reflection. Notice each point here, each corresponding point is 1 point away, or 1 unit away from the line of reflection. And the same is true for these 2 points. And for the far points, they are 1, 2, 3, 4 away, 1, 2, 3, 4 away. And we could find the same to be true over the y-axis. So, if we take a look at an example, it says triangle ABC has those vertices. Graph the figure and its reflected image over the x-axis, then find the coordinates of the vertices of the reflected image. Okay, so if we start by graphing A, which is 5, 2, there was the problem. 5, 2 for A, 1, 2, 3, 4, 5, 1, 2. A. B is 1, 3. C is -1, 1. So those are my vertices. Connect the dots here. Now I want to reflect it over the x-axis. Okay, I want to reflect it over the x-axis. So this is the x-axis. If point C is 1 unit away from the x-axis, I know point C prime must be 1 unit away the opposite direction. C prime. Then I go to B. B is 1, 2, 3 units away. So now I go 1, 2, 3 units away down here. B prime. And A is 2 units away, so on that same vertical line I go 2 units down. Okay, and I have A prime. And once I connect these dots here, you'll see I have a perfect mirror image of triangle ABC reflected across the x-axis. Okay, see how it just flips down. Okay, now I can't forget about the second part of the problem, and that is listing the vertices. A prime are the coordinates 1, 2, 3, 4, 1, 2, 3, 4, 5, -2. B prime would be 1, -3. And C prime would be -1, -1. Okay, so these are my coordinates. Now, if you notice, compared to our originals up here, the y coordinates are the same except they're all negative. The x coordinates stay exactly the same. Okay, so if we'd wanted to, we could find the coordinates without graphing or without counting. Take a look at example number 2. Now we're working with a quadrilateral. Quadrilateral KLMN has vertices KL and M and N. Graph the figure and its reflection over the y-axis, then find the coordinates of the vertices of the reflected image. So we start by graphing K, L, M, and N. 2, 3. L is 5, 1. 1, 2, 3, 4, 5. M is 4, -2. 1, 2, 3, 4. 1, 2. And N is 1, -1. So we connect the dots here. And we see we have a quadrilateral, which is the fancy name for a four-sided figure. Now I need to reflect that over the y-axis. So the y-axis is my line of reflection. So I can take them one point at a time here. And N is 1 unit away to the right. So N prime would be 1 unit to the left. M is 1, 2, 3, 4 units away. So over here I'll go 4 units, 1, 2, 3, 4, and put a point. That'll be M prime. Okay. L prime is 1, 2, 3, 4, 5 units. So on the other side I go 1, 2, 3, 4, 5. And K is 2 units, so K prime, oops, I better label L prime here. So K prime would be 2 units the other way. And once again, when you connect the dots, you have a perfect mirror image reflected across the y-axis. And there you have it. So go ahead and try A on your own, please. Try A on your own. I'll be back in a minute to take you through it. Okay, you should be back from trying A on your own. This time we're working with a triangle PQR. So as always, we start by graphing our pre-image, or where we started. So P is 1, 5. 1, 1, 2, 3, 4, 5. That is P. Q is 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. And R is 4, -1. 1, 2, 3, 4, -1. So this time, for this example, I'm going to show you a little bit different way to do it other than counting. Over to the other side. You can always definitely count, but sometimes you might not be given a graph and you don't want to make a graph, so there are other ways to do it. So just like yesterday, when we talked about translations, we can use transformation notation to help us find those new vertices. So here are my original vertices. Again, I'm going to write my transformation at the top. X comma y turns into. Now, if I'm reflecting over the y-axis, I need to change the sign of my x-coordinate. So this becomes negative x comma y. So when I do that, p turns to p prime. Okay, now my x-coordinate was 1, so now I need to have negative x, so that would be negative 1. My y-coordinate was 5. We didn't do anything to the y-coordinate, so we leave it at 5. Q prime, my x-coordinate was 3, so then I would need to have my negative x-coordinate, which would be negative 3. My y-coordinate was 7. We didn't do anything to the y-coordinate. It stays 7. And lastly, r turns to r prime. So 4 was my x-coordinate. That turns to a negative x, so that would be a negative 4. And my y-coordinate stays the same, so it's negative 1. Okay, so those are all of my new coordinates, and now all I have to do is graph them. So p prime is negative 1 comma 5. There's p prime. Q prime would be negative 3, 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. All the way up there. Q prime. And r prime would be negative 4. Negative 1. And yet again, you see a perfect mirror image. Once we connect the dots. And there you have it. So I would really encourage you to use this style. I think it's helpful, especially if you get into word problems. You're definitely going to need to know these transformation notation rules. So again, just to refresh your memory, if we reflect across the y-axis, we need to change the sign of the x-coordinate. If we reflect across the x-axis, we change the sign of the y. So if we take a look at example 3 here, it gives us another kind of real world example talking about like animation. So generally when figures are animated, you're only going to sketch or create half of it and then reflect it for the other half, because a lot of figures, most figures, people's faces, people's bodies, a frog, are symmetric from one side to the other. So if you can draw one side and reflect it, it takes half the time to draw whatever you're drawing. So here we have the figure below is reflected across the y-axis. Find the coordinates of A prime and B prime, then sketch the figure and its image on the coordinate plane. Okay, so again, I want to reiterate those transformation notations, x comma y. If we're reflecting across the y-axis, we need to change the sign of the x. Okay, so A are the coordinates 1, comma 1, 2, 3, 4. And B has the coordinates of 2, comma 1. So that means A prime, since I changed the sign on my x, is negative 1, comma 4. And B prime would be negative 2, comma 1. Okay, so I graph these points, negative 2, comma 1. There's B prime. And negative 1, comma 4. There's A prime. So now what this allows me to do is sketch in the rest of this frog using these aiming points. So believe me when I tell you, I am no artist here, but I'll do the best I can. To kind of get this frog drawn here. He's got a little toe and another toe, and there's this last toe. All right, so not a great artist rendition of the second half of a frog, but once you have these aiming points, it is definitely easier than just trying to freehand it. If we had more points, it'd probably be even easier. The main point here, transformation notation, being able to find the coordinates of those points. Go ahead and try B on your own. Pause the video. I'll be back in a minute to discuss it with you. Okay, you should be back from trying B on your own. This time we're going to transform the figure or reflect the figure across the x-axis. So again, we want our transformation notation. This time, since we're reflecting across the x-axis, we change the sign on the y-coordinate. Okay, so I start with A. My coordinates would be -2, 2. B, my coordinates are 2, 2. So when I change it, my x coordinates stay the same and my y coordinates change the sign. So I have -2, -2, and 2, -2. So here you go. A prime would be -2. Oops, I should have labeled those. A prime, B prime. -2, -2, A prime, 2, -2, B prime. So let's see how, see how Mr. Green does this time. Drawing them in. Looks something like that. And like that. And there you have it. There's the second part of that sun. Again, the main point is transformation notation. Reflecting across the x-axis changes the y-coordinate. So here's the assignment. You should be able to read those. Red, yellow, green. I know the colors are a little messed up because of the filter, but it's easier to read that way. So go ahead, do the assignment that you feel you are ready for. If you understood everything, it's super easy, do the green. If you're good on some parts, stuck on others, do the yellow. And if you struggled a little bit today, do the red assignment. Reminder, when you reflect across the x-axis, change the y-coordinate. And when you reflect across the y-axis, change the x-coordinate. And the way you change them is you change the sign. Okay, you multiply them by a -1. Right. Thanks, and as always, have a great day.